Long before human civilization emerged, the cosmic stage has been hosting countless awe-inspiring dramas. On a September night in 2020, while most of the world slumbered, the Large Synoptic Survey Telescope LSST in the Atacama Desert of Chile, with its giant 3.2 billion pixel eye, scanned the northern sky tirelessly. Suddenly, an alarm shattered the silence in the observatory. Flashing red warning signs on the screen immediately drew astronomers' attention to a region in the constellation Pegasus, 12,000 light-years away. There, an orange dwarf star designated HD 21749 was undergoing a celestial event poised to rewrite the textbooks of astronomy. In traditional astronomical understanding, the engulfment of planets by stars was considered an instinctive act during the red giant phase of a star's late life cycle. For instance, in about 5 billion years, our Sun will expand into a red giant, swelling to a size that exceeds the orbit of Mars. By then, Mercury, Venus, and possibly even Earth could become its cosmic prey. However, the anomalous behavior of HD 21749 has completely upended this established view. With a mass only 70% that of the Sun, this star is currently in the prime of its life, at least 4 billion years away from evolving into a red giant, yet it has prematurely staged a drama typically reserved for a star's twilight years. The research team swiftly activated a global observation network. The Keck Observatory in Hawaii and the Very Large Telescope VLT of the European Southern Observatory turned their lenses towards this enigmatic star. Spectral analysis revealed abnormal absorption lines, characteristics that matched neither supernova explosions nor typical stellar mergers. What puzzled scientists even more was that the optical transient's brightness was merely 1/10 of the expected value, resembling a cosmic symphony with its volume inexplicably turned down. It wasn't until April 2025, through high-resolution observations by the Atacama Large Millimeter, Sub-Millimeter Array ALMA, that the complete picture finally emerged. The star had consumed a gas giant planet with a mass somewhere between that of Neptune and Jupiter. Its fate had been sealed millions of years ago. Under the star's powerful tidal forces, the planet's orbit contracted imperceptibly, as if being pulled by an invisible thread towards the searing abyss. When the distance reached a critical threshold, the planet's outer atmosphere was first stripped away, forming a material stream stretching millions of kilometers. Eventually, the core slammed into the star's surface at a speed exceeding 500 kilometers per second. This intense collision, which lasted several days, ejected the star's outer layers into interstellar space, creating a ring of dust composed of silicates and ice particles that glowed uniquely in the infrared spectrum. The lead scientist of the study marveled in the Astrophysical Journal paper, "It's like discovering an oasis in the Sahara. We've witnessed the perfect convergence of theoretical predictions and observational reality." This discovery not only confirms the possibility of main sequence stars engulfing planets, but also reveals the complexity of planetary system evolution. Those seemingly stable celestial orbits hide crises that could erupt at any moment. Shifting our gaze to Proxima Centauri, a mere 4.2 light-years from Earth, this once promising cradle of life is now the stage for a terrifying cosmic tempest. As a red dwarf star with a surface temperature of only 3000 Kelvin and a mass just 12% of the Sun's, Proxima Centauri packs an explosive punch far beyond expectations. In a study published in March 2025, an international team of astronomers used the ALMA telescope to conduct unprecedented millimeter-wave observations of this star. The results were staggering. Proxima Centauri unleashed 463 flares within just 48 hours. The most intense of these flares saw its brightness surge 1,000-fold in 16 seconds, releasing an energy equivalent to 1,025 joules, comparable to a moderate solar flare, despite Proxima Centauri's mass being only 1/10 that of the Sun. What's more disconcerting is that these flares were predominantly concentrated in the millimeter wave band, marking the first time humanity has observed such high-frequency stellar activity at this wavelength. Traditionally, scientists studied stellar flares using visible light and X-ray bands. However, the unique nature of Proxima Centauri necessitated a methodological revolution. Comprising 16 antennas in an interferometric array, ALMA achieved an observation resolution of 0.1 arcseconds, equivalent to being able to read a newspaper headline in New York from Beijing. The study revealed that the star's internal structure is the root cause of its temperamental behavior. Lacking a radiative zone like the Sun, Proxima Centauri is almost entirely convective, resulting in extremely intense magnetic field activity. Magnetic loops emerge and erupt like boiling magma, fueling the star's frequent and powerful outbursts. What does this relentless cosmic tempest mean for Proxima Centauri b, the Earth-like planet situated in the star's habitable zone? Research indicates that without the protection of a robust magnetic field and a thick atmosphere, the planet's atmosphere would be completely stripped away within 10 million years under such frequent flare bombardments. Even worse, millimeter-wave flares may be accompanied by high-energy ultraviolet radiation, which would directly destroy organic molecules on the planet's surface, posing a fatal threat to the emergence and evolution of life. As the paper's authors put it, we may need to redefine the concept of the habitable zone. It's not just about temperature anymore. We must also take into account a star's temperament. On the opposite end of the solar system, Saturn is quietly building an astonishing satellite empire. In 2019, astronomers using the Subaru telescope in Hawaii discovered 20 new satellites around Saturn in one fell swoop, breaking Jupiter's long-held record for the most satellites among the planets. By 2024, the number experienced an explosive growth. The Minor Planets Center of the International Astronomical Union announced the confirmation of 128 additional satellites, bringing Saturn's total to a staggering 274. This number exceeds the combined total of satellites of all other planets in the solar system. These newly discovered satellites exhibit a unique beauty in chaos. Their orbital inclinations can reach up to 150 degrees, and their eccentricities exceed 0.7, standing in stark contrast to the orderly orbits of Saturn's rings and its larger, more traditional moons. In terms of orbital direction, over 60% of these satellites orbit in the opposite direction of Saturn's rotation, resembling a fleet of interstellar ships moving in reverse. Their orbital radii stretch up to 18 million kilometers, 50 times the radius of Titan's orbit. Through computer simulations, scientists have proposed two possible formation mechanisms. The first is the gravitational capture hypothesis. With its immense gravitational pull, Saturn acts like a cosmic fisherman, snagging passing asteroids. The second is the collision debris hypothesis, suggesting that these satellites are remnants from violent collisions in the early days of the solar system, which were then drawn together by Saturn's gravity. What makes this discovery even more intriguing is that these small satellites are generally less than 100 million years old, closely matching the estimated age of Saturn's rings. This similarity hints at a possible connection, suggesting they might all be products of the same cosmic event. To test these hypotheses, NASA plans to launch the Saturn orbiter in the 2030s. Equipped with high-resolution imaging spectrometers and radar detection devices, this spacecraft will conduct close-range studies of these mysterious satellites. Scientists hope that by analyzing their compositions and orbital characteristics, they can unlock the secrets behind the formation of Saturn's satellite empire. This research could not only shed light on the evolution of the Saturnian system, but also provide crucial clues to understanding the early history of the solar system. From the spectacular sight of a star devouring a planet, to the menacing storms of Proxima Centauri, and the enigma of Saturn's satellite empire, these latest discoveries continuously push the boundaries of human knowledge about the universe. Each observational breakthrough is like deciphering a new chapter in the vast tome of the cosmos, and every new discovery redefines our understanding of life and existence. In the observatories of the Atacama Desert, telescope lenses continue to scan the starry sky tirelessly. In laboratories around the globe, scientists use supercomputers to simulate the evolution of the universe. Humanity's exploration of the cosmos is driven not only by curiosity about the unknown, but also by a profound quest to understand our own existence. As Carl Sagan once said, the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, and the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. In this vast and boundless universe, humanity may be as tiny as specks of dust. Yet, it is precisely this persistent pursuit of the unknown that allows us to reach for the stars and decode the universe's mysteries. With the deployment of more powerful observatories like the James Webb Space Telescope and the Square Kilometre Array SCO in the future, what other cosmic wonders await discovery? The answers may lie hidden in the next set of observational data, waiting for humanity to uncover them.